Hey everybody, this is Gabriel Cardona. Welcome to another episode of the Subnet Show. I am joined as always by my co-host Connor Daly. What is up, Connor?
Hey, not too much. Thanks for having me, Gabriel.
Yes, as always, thanks for being here. And tonight, we are incredibly fortunate. We have an extra special guest. We have with us tonight Stephen Buttolph. Stephen is the lead of the platform team at Ava Labs. He is the creator of AvalancheGo, and he is an absolute all-around block star. Thanks for joining us. How are you doing, man?
I'm doing great. Just happy to be here. Thanks for the invite.
Yeah, super glad to get you on board. As I was saying before we started, I think you're like one of the shadowy, mysterious rock stars in our ecosystem. And I know a ton of people have wanted to get to know more about you. So it was my intention once we got the ball rolling here to have you on as soon as possible, just to get a sense of your crypto story, your crypto vision, and what you think about where we're at, where we're headed, all those fun things. So traditionally, our format has been that we kind of open up with just talking about a few different news items because there's so much stuff happening in our ecosystem. And then we pivot into kind of the main topic, which is just, digging into your story and everything. So I think to start off with the news, and a couple of these are relate to Connor. So I think he can shine a lot of insight. So I think the very first thing on our list is that this week, there was a new release. This week, a better way to say it is that another huge milestone was achieved in the journey of Avalanche becoming the premier platform for licensed NFTs.
Yeah,
and
absolutely.
so a huge milestone. The Bundesliga collection went live on Avalanche yesterday, I believe. Connor was the at the heart of that whole project. So I'll pass the mic to you, Connor, if you want to talk about that and how that all went down.
Yeah, so this was the second content release that for our Topps NFT collaboration. So the first of which was Bazooka Joe, which launched a few weeks ago now. But now, many of our listeners may not have heard of Bazooka Joe before this launch, but a lot of people have heard of a game called soccer, and or excuse me, football.
There you go.
And as somebody who spent a lot of time in Germany growing up, I was really excited to see Bundesliga, the German Football Federation, come to Avalanche. And there were some really awesome packs, some really awesome collectibles that dropped, and it was super exciting. The community was really into it. Everyone was really hyped to see a real license that people really cared about. And there was a ton of interest. We sold like tens of thousands of packs, and it was a really a big success. And one thing I want to take a personal pride in is that I've been one of the first people to ever build on like the Avalanche C chain, like going back into like last year in October, November, when I was actually starting some work on Penguin and stuff like that. I was really like one of the few people actually spending AVAX and building platforms. So I was looking at burned AVAX on Avascan yesterday. And now addresses that I have created or control in some way. Now I used to be like by far and away the number one address. Then I lost that, and the arbitrage bot took number one. But I have reclaimed my spot at number one and number three for the most burned AVAX in the ecosystem.
That's amazing.
Yeah,
You're cornering the entire market, man. Like
I am wasting so much money right now.
You alone are driving the price up just from the deflationary pressure.
Yeah, no, it's really crazy. Yeah, we burned like maybe like 5,000 AVAX yesterday just from Bundesliga alone. And it's been, hugely popular so far. Really great community reception. I know there's still some problems on the website, but trust me, the team is working really hard on resolving all of those for payments and stuff like that. And that will get smoothed out with time. But we've really shown that we have some product market fit there, and that people want these things. And if we can bring the best licenses in the world to our platform, there's going to be people who are wanting to buy that. And that's super exciting for us.
Yeah, and it has been like, as he was saying, maybe there's still some problems or something, but really, it's just been such an eye opener into the Rube Goldberg machine that is the traditional finance rails. Again, I'm sure Connor can speak to this 1,000 times more than myself because he really fell down the rabbit hole. But it's just crazy. You get a sense of just how much better crypto is really when you start peeling off the layers and get a sense of how credit card payments work with integration with banks and with integration with payment providers and tokenized credit cards and all of this different stuff that's happening behind the scenes. It's insane.
It really is. It's just like, it seems so simple. How can I just send someone money? And if you're a crypto native, you know that, oh, I just send them a transaction and they get it. Or, I mean, if you're a mobile native, you're like, well, I can Venmo them. But, you know, companies don't really have Venmo. They have like reporting requirements. There's legal things you have to worry about for reporting and for different operating in different countries and what the different regulations are there. And there's so much that goes into it. But even just from a technological perspective, you know, it's very hard to do high throughput on traditional payment systems. This is like the PlayStation 5 ordering problem or these packs and releases. Like, it's actually just hard to sell a lot of stuff at a single time. And that's why, you know, there's a lot of queues that you get put into before you go onto a site. And with or just that your transactions fail when you actually execute them. And this is where something like Avalanche could really make a huge difference, because if you ran that on the X chain, there wouldn't be any queue, there wouldn't be any wait time, your transactions would just process. Even the C chain would do incredibly well, you know, for quite high load. So, I mean, this is where crypto is the future. This is where I feel more confident in that every day, is just looking at these traditional payment rails and just thinking, man, I could build a better app for this in using crypto in like a week. Like there's so much opportunity here.
And there are literally like roadblocks that we have to put in place because we can't just send so many transactions through. Is that correct?
Oh yeah. Yeah. So, you know, we talk to different payment providers and they give us different like rate limits of what they think they can support. Sometimes what they think they can support is not what they can actually support, but other times they, you know, hard cap it of like, you know, we can only do 300 TPS or something like that. And so we have to be careful about how do we not exceed that, because then when we start getting rate limited, then that just causes cascading issues that you have to worry about on the engineering side of like, now, how do I reissue this transaction? You know, how do I make sure that I'm not holding the user's credit card for too long? And then I introduce some like regulatory compliance or anything like that.
Yeah, because that's another thing, is that there's PCI compliance with anything to do with credit cards. So like if anybody's ever built a site like this, I wasn't familiar with this until this particular project, but if the credit card number touches your backend at all, then you have to be PCI compliant. So there's services which literally just do this tokenized credit card thing where you drop like an iframe in your site, and when the person puts the credit card number, it never hits your server at all. And then you just pass around like a tokenized representation of that. That was something that was kind of new to me.
So Stephen, have you bought any NFTs?
I haven't bought any NFTs, but I've had a couple very generously gifted to me. So this whole conversation has actually been really interesting for me because I'm like a pure backend like platform guy. And so I haven't had to deal with any of these like, you know, credit card processing like issues. So it's actually really interesting just for me to kind of to hear like some of the issues that you guys are dealing with, just because yeah, it's just kind of something that I don't typically see. So
yeah, so to contextualize this a little bit, yeah, Stephen very much works on the core protocol of like the actual blockchain data structures, making sure that the trie is doing all the things the trie is supposed to do, and you know, making sure that Avalanche is processing transactions quickly, safely, and securely. Whereas, you know, Gabriel does a lot more work with developer services and AvalancheJS, which is AvalancheJS is also a platform side, kind of interfacing with the platform, you know, in the node environment, and also working with other partners to help bring them into the ecosystem and just spreading the good news, because he's got some good vibes.
Thank you. And yeah, I wanted to go back to, so I think if I'm correct, the network burned, I think 4,000 or 5,000 AVAX yesterday-ish. There's a really great chart of the C chain burning, and it's like, boom. And so somebody pointed out to me, you know, that's like 2 validators worth of AVAX. And it got me thinking about a conversation I had with Stephen. So Stephen has been around since the very beginning, and we can touch on this more, I guess, as we go into his story in a bit. But I wanted to confirm, Connor, whenever you were telling me your story, do I remember correctly that you said in the very, very beginning of the lab, it was you, Michael, and Stephen, or am I misremembering?
No, I'm sorry. I've only been, I mean, I was here after you.
I'm talking about at Cornell. I thought
at Cornell. No, it was just me. I'm actually older than all these guys.
Okay, Got it. For some reason, I thought you told me whenever you were doing the op return thing that Michael and Stephen were the only two people in the lab back then, but I guess
I think you're confusing Dan's story.
Okay, yeah, possibly. Okay, yeah, so what I was going to say is I remember myself and Stephen had a conversation when I first started about the fixed cap asset nature of AVAX and burning fees and everything. And I wanted to see, do you have any memories about how that conversation went down? Like, was it super heated? How did it ultimately come to, the decision of having a fixed cap asset and then also burning fees and that whole thing?
So we had early on, we had a lot of conversations about this. So really early on, it was kind of me, Goon, Kevin, Ted, and Amani Moyne, who no longer works at the company now, but she was basically a PhD economist that we were interfacing with. And so very early on, the plan was to be fixed cap. Then we actually changed the plan to be variable cap. Then it was like that for a while. And then we ended up once it was a little bit more, things were kind of starting to heat up. We eventually ended up kind of talking to the community, figuring out what people wanted. There's an overwhelming response for a fixed cap asset from the community. And so I will say I was a staunch supporter of variable cap, believe it or not. Mm-hmm. And we could talk about reasons why that, but eventually, we ended up kind of talking and with both the community and also some of our additional advisors, we ended up deciding to go down the fixed cap route. So at that point, we kind of went there and never looked back. So pretty happy with that.
Sure. And what were your, you said you were a staunch supporter of it. I think the intuition that people have is that if there's only a certain amount of something and you're burning, eventually it's going to run out, right? That's sort of like the initial intuition. And so I think that's the thing that people run up against immediately.
Yeah. So with the addition of dynamic fees, which we're planning on releasing sometime this quarter, we're hoping to get out. Once you add in dynamic fees, it's less of a concern because what ends up happening is, as the supply goes down, what eventually happens is, it becomes more scarce. And so, if the market cap were to stay the same, then the price of each token goes up, which causes the actual amount of AVAX to go down on the fee. So it isn't like a real concern that you're going to run out of supply because the fee is going to eventually it's eventually going to make it so that it's not really a concern. But it is definitely kind of one thing that's a bit of like a mental gymnastics that people have to go through. But yeah, so that's kind of the answer of why that isn't like a huge concern, at least from the platform side.
So I don't want to steal the thunder from our topic of the show, but I just you kind of brought an interesting question to mind. So what would you think are the big pivot points that Avalanche has had? So you mentioned, there was the discussion of going, the fixed to variable. I guess what are the other things that were changes or decisions that were made?
So there, when you're developing like a huge, ecosystem like this, there's a lot of things that have been made. So, I mean, to start, when I was first working on developing AvalancheGo, at the time it was actually called Gecko. So it's
I forgot about Gecko. That's right.
Yeah.
I didn't know that.
Yeah. So Gecko was originally just a DAG with just payments, and then we ended up working on adding in a proof of stake element. And in doing so, we decided to use a chain for that. So we ended up creating Snowman to support the staking chain, or the platform VM as it's now, or the P chain as it's now called.
So for anyone who doesn't know what Snowman is, could you explain that real quick?
Yeah. So Snowman is essentially a subset of Avalanche where it's just a linear chain. So in Avalanche, you have a DAG, which is a partially ordered data structure. I have a whiteboard here, but I don't think this is the context for that kind of a conversation. But anyways, so essentially you have partial ordering. So you might have transaction A, transaction B. if they aren't dependent on each other, they can kind of happen at the same time. So you don't need to like totally order all transactions linearly. Whereas in Snowman, it's a much more standard blockchain based, it's same as Bitcoin or kind of Ethereum, although Ethereum actually has uncles and stuff. But anyways, so in Bitcoin, you just have, one parent block and everything's totally ordered. So Snowman is essentially a subset of Avalanche in that regard, but it lets us do a couple optimizations that if we just added simple restrictions to Avalanche, we couldn't do. So that's what Snowman.
And so how did you, what was your thinking about starting with a DAG and doing payments instead of smart contracts? How did that start?
So the original Avalanche paper is just a DAG. So that was kind of how it started. And essentially the way it was tasked was I went to Goon and said, hey, I'm really interested in working with you. And I just saw this paper. And he said, yeah, would love to work with you. Go implement Avalanche. Yeah, and he said, what programming languages do you know? And at the time I was a sophomore at college. So I said, I know Java, Python, C, and C++. And he said, cool, pick either Go or Rust and let's make a client in that. And so with not enough research done, to be perfectly honest, I said, all right, I'll do Go. And so that's why Go was what we worked on. Looking back, I'm very happy that I picked Go just because I think that it's easier to onboard people. I love Rust as a programming language, but it certainly can be harder sometimes to onboard people. I have found. Of course, I've now spent a lot more time in Go than I have in Rust, and so maybe this is a jaded opinion, but but yeah. So that's how that got started. Yeah.
Got it. And then so. Yeah, we don't have to stay to the format of doing news or whatever. I'm more than happy to just go with the conversation of the flow of the conversation. So I remember asking you in the past as well this question. So what was it like then going from, so we have this white paper, it describes a DAG. Now we're going to add a proof of stake component and there's a linear chain and presumably we can do contracts to, we have a platform of platforms. We have the Avalanche network, we have subnets. How did that happen? Because that's a big leap and the platform is where the special sauce is.
Yeah, so kind of touching back on, so originally we had mainly the DAG and we had planned on adding the Snowman for staking. And Goon's kind of original, Goon had this idea that he was wanted to get in, which is the idea of having these things. It was called colored nodes at the time. So he wanted, essentially, you'd have the blue nodes in the network and you would have like the red nodes in the network, and the blue nodes know how to validate blue transactions and the red nodes know how to validate the red transactions. And essentially he wanted to kind of have this like heterogeneous network where just because it's a transaction doesn't necessarily mean that all the nodes in the network know how to validate it. So that was kind of the original idea, and we went back and forth with, well, how can we kind of intermingle these things? How can we, move these assets around in meaningful ways without everyone in the network knowing? And so eventually what came out of that was we said, okay, well, how are we going to define just what these transactions even look like? Because the blue nodes have to actually understand what a blue transaction is, right? And so that was when we went down the route of, okay, well, like we need to have a platform where you can add extensions to it and add kind of your own custom things. And so we ended up doing a plugin based model for what is now VMs. And so the VM defines, well, how do I, process a blue transaction? Well, do you have the blue VM that, is able to read and process these things? And then the distinction of what is a blue node or a red node, and of course, these aren't necessarily disjoint things. There might be like some nodes are both blue and red, which we called purple nodes at the time. But anyways, and that is kind of how we ended up going down like the subnet route, where the subnet definition is all the nodes that are blue, end up owning kind of all these state transitions in the blue side, and the red subnet ends up managing the validators that are red, and they achieve consensus there. So essentially, the idea came from Goon on wanting to have a heterogeneous network, and then we essentially kind of took that idea and refined it down, and eventually came up with this subnet-based, VM-based structure that we have now. So yeah.
Do you remember the moment? Like, do you remember when it came together? Was it an aha moment?
Yeah, it was totally an aha moment. So I was in a hotel room with Kevin, and I was basically talking with him when I said like basically when I was like, oh yeah, these should be plugins that like define these things, and then like users can attach them as they want with like the client. And I remember talking with Goon afterwards. I was like super excited. I was like, yo, this makes so much sense. It's gonna be so cool. And he was like, yeah, no, that's like exactly what I was thinking. I was like, yeah. I was like, I probably should have been talking with what your idea, because like Goon is like, so Goon's history before, he's been involved in the crypto space obviously like forever, pre-Bitcoin with his Karma stuff. But he's also, and I say this like it's the side thing. It's his main thing, or at least it was at the time, his operating systems. And so he was kind of one of the pioneers of these like what eventually became like applets, which is basically just kind of like ways of having a more modular operating system and things like that. I apologize for the operating system buffs, because while I did take operating systems with Goon, I'm probably butchering all of this. But anyways, so he definitely had this kind of in mind, and I ended up kind of rediscovering it. But anyways, it was definitely an aha moment for me at least. But but yeah, it was really cool.
So then, what was your I guess let's just go ahead and get into your history, because I was going to ask you what was your blockchain history, but let's go back a little step before that. Where did you grow up?
Yeah, so I was born and raised in central New Hampshire. Super avid skier, love skiing. I started ski racing when I was 4 years old.
Nice.
And been skiing ever since. So I grew up there, went to high school there, and then eventually went to Cornell for college. And my family is very Cornell focused family for one reason or another. So I have two brothers, and both of my older brothers went to Cornell. And so it was kind of we all just kind of like fed into the Cornell sphere. But
that's interesting that your parents were, that says a lot about your parents, really, that they were able to really have three sons who all made it to Cornell, instead of somebody going astray or whatever. That's pretty cool.
Yeah, so kind of diving back a little bit more. So I was actually homeschooled until high school by my mom. And my mom is definitely like extremely academic focused person. And so by the time we ended up going into high school, we were very advanced in math and sciences. So definitely like a lot of my academic like focused traits are definitely come directly from my mom. So
wow, massive props to your mom. I'm sure she appreciates how great you are, but man, like massive props to your mom. Like I said it when I started working, and I say it to Connor as well, like you guys are both incredibly good engineers, great engineers, and I know you guys are going to accomplish some amazing stuff in your career. How did you discover computer science? What did that journey look like?
Yeah, so my middle brother took a CS class in high school, and I was very math focused. I was pretty good at math, but I didn't really love math. Like it wasn't like I just loved doing math, but I was really good at it. And so he was basically like, yo, you should take like a CS class. So I tried to take the CS class at the high school. It was actually full, so I ended up taking an online course. And pretty much like halfway through the course or something, like freshman year of high school, I was just like, yeah, this is what I'm gonna do. Like there was no doubt. Like
What year was this?
2012.
So what
2012.
language would you have been learning? Like Java or web stuff or what?
So the first language I touched was Python, and I did that for like half a semester, and then I did some Java. And so it was Java and Python were kind of the start. And then after doing a little bit Java, there was VB, like Visual Basic.
I was wondering if it was still around though. So they still teach it?
Yeah, they were still teaching it, which was a little more UI heavy than like Python or Java, which was fun for a high schooler. And then I did some C and C++.
VB is definitely like a high school class language that they would teach you.
Yeah, because you get to make a game or whatever. Like you get to do this.
Just
I remember
behind the times enough.
Yeah, I remember one of my projects, it was just like build like whatever you want. I basically ended up building like a video game builder, and I always joked about how like Mario Maker, they stole my idea, which I think it actually came out at around the same time, so it was like timely. But anyways,
what was your first like your first love with regards to programming languages? What was the one that got you?
I think the one that I spent the most time on was Java, which is a controversial topic. I think a lot of people don't particularly love Java, especially if they've been in the industry. But I don't know. I thought it was pretty nice. It was definitely the one that I got the deepest into. So I was very much a Java expert for a couple years, and I haven't touched Java in a while, so it's a little rusty now. But yeah, I think Java was kind of my main language for a while.
Yeah. I think Java is a pretty good language to start with because it actually, like, unlike Python, it actually shows you like what you can do with things like types or whatever without like totally throwing you to the wolves with like C pointers and stuff like that. So you don't have to worry about all of your seg faults so much, but you do start to unlock that like next tier of like how the language actually works rather than just like I'm like adding numbers together with Python.
Yeah, no, I have like a Stack Overflow question. It was basically like the first time I touched C++, and I was like just mind blown because I had like this very stupid like whatever thing, and basically I had like a debug for loop in there, and when I had the for loop in there, the code worked fine, and then when I removed the for loop, it didn't work and it crashed. And I, being naive at the time, I had no idea about like uninitialized memory and like stuff like that, and that was the problem. And so basically, when you had the for loop there, it was wiping the memory that was then being later reused. But anyways, so I was just like mind blown, where I was like, I have like an empty for loop that's iterating from 0 to 9, and it works if I include it. And it was like, yeah, and I had that was one of my very first like programming endeavors into C++, and I was like, I miss Java. Like, what's going on?
That sounds like the bug you talked about, Connor, when you were doing hardware and you had to put in some type of like debug or something to get it to work.
That's what I was thinking of. Yeah, I had a thing last summer 2020. I spent literally a week trying to solve this issue. I was working on a custom like microkernel operating system, and if I added the print statement, it would work. And if I removed the print statement, it wouldn't. Because it turned out that it was the G-Node operating system. It turned out that the networking driver like was not buffering the input from the NIC properly. It would accept the HTTP connection, but before it would like allow you to read from the socket, there was like a period of time where it would just drop any input that was sent to it. So you had to open the socket, wait a second, and then send your data to it. And I was working on the client, and that just drove me crazy. I spent like a week on it.
Hardware is hard always. Stephen, have you dug into any other JVM languages like Kotlin, or did you just do Java?
Yeah, no, I looked into what's it called? I didn't look into Kotlin, but it's the like functional extension.
Are you a functional guy? Wait.
no, crap, what was it? I forget the name of it. I have played around with it. At Cornell, they require you to learn like functional languages. So like OCaml is basically the language they teach there. And so at the time I was like, I don't know, like these functional languages are pretty cool. So I ended up looking a bit into that. And so I'm gonna remember it like halfway through this podcast on like what the name of the language is. But yeah, I played around with it. I think at the time that was kind of towards the end of me using Java, to be perfectly honest. Really once I truly understood like how computers worked, so like once I took like computer architecture, then I was like, okay, like get this out of here. Like I want to code in C. Just because yeah, I just really like kind of the flexibility of it. So
I was going to follow up with
yeah.
Connor's question and say, do you think in a functional way or do you think object oriented? But if you're doing C, you're not thinking object oriented, right?
I think it depends a lot on the situation. I definitely like nice object oriented abstractions. And I'm a huge fan of just data structures in general, which oftentimes like those kind of go nicely. But yeah, I don't know. Like I would say it really depends a lot. Like in like Go, right? Like there aren't really objects at all. But you have like structs, interfaces, and then in C it's the Wild West of like you can do whatever you want. But yeah, so I don't know. I would say like because of all my time that I've spent in Java, I definitely like object-oriented thinking. But yeah, I think I don't know, being well-rounded, just kind of like knowing about a bunch of different patterns makes you a better coder.
Yeah, I personally think I think most naturally in like an object-oriented class hierarchy. Inheritance, those things just seem very natural to me. You can abstract common functionality into an ancestor and extend it. I will say that JavaScript having prototypal inheritance, even now with the class keyword, it's just syntactic sugar over prototypes, has always been a bit confusing to me. And I've always wondered what Brandon Ike's decision making was there. I think Brandon Ike is so awesome. And I would love to, I think he did an interview somewhere on this, but I think somebody should, corner him and have him do a crazy multi-series deep dive on. They created JavaScript in 6 days, and so it would just be so interesting to know, like, what there was so much pressure of Netscape, IPO, and big money. I'm sure Microsoft is going to kill us and all this stuff, and then they give birth to JavaScript, which ends up being just this crazy Frankenstein beast that goes on to become the biggest runtime in all of history. And there's just so many interesting decisions and prototypal inheritance. I could be wrong here. Does Scheme have prototypal inheritance? I feel like that's where he got the influence. I could be wrong about that though. Okay, so to steer it back on track. So then you said your middle brother had discovered computer science and he turned you onto it. And then so you were studying this in high school?
Yeah. So I started CS in high school and basically worked on it constantly.
And so you said you knew then this is what I'm going to do.
Yeah, it was so at the time, so I have two older brothers. And so my oldest brother, around me when I was a freshman, he was going to college. And so, he was like, kind of trying to decide what he wanted to do on whether or not he was, he's currently now doing his PhD in physics. Nice. Like lasers specifically.
That ain't easy.
Yeah, not easy at all. But yeah, at the time he was kind of going back and forth. Originally, he had kind of wanted to do med school, and then he did like some stuff at a local hospital, and then he decided, okay, maybe not. But but anyways, so kind of like when that conversation was going on, I literally like went to my parents like, don't worry, I'm gonna make it easy for you. I'm gonna do CS, and like I had no idea like CS is an extremely like good career, right? Like it's very like in demand. Sure. And I had no idea about that. So like I was like, yeah, I'm gonna like do CS, and my parents were like, cool, well, he's gonna like be able to get a job in that. So that's cool for them. And it just really worked out that yeah, I just really loved it. I spent a lot of time like just coding random stuff, and so like I coded like a chat like group message app basically, and I was like trying to get my like friends to use it in high school. Of course, no one wants to use it, right? 'Cause it's, like why? But I was like, I don't know, it's cool. I built it. So
Were you
Um,
kind of like, did you have a natural intuition for, I guess, two things? What were your thoughts on open source and then, or licensing, I guess, in general? And then what were your thoughts on like startup culture? If you were relatively young and ambitious, did you naturally say, I want to start a startup, or was that not on your radar?
wasn't a thought at all. I had no plans. I wasn't thinking about licensing. I wasn't doing it. I was just like coding. Like if I was saving something, I was putting it on a USB, and I was like, cool. Like that's
Did you use
like,
version control? Did you have version
no,
control?
I didn't. I don't even know when I started using so like my high school what is like not like known for CS. So like basically I was just like doing classes, and like none of my classes did version control, which is like wild to think about. Like it's so integral with
Totally.
like everything. But anyway, so yeah, like I think the first time I ever even touched Git was in Cornell.
Mm.
Like it was a long time. Like yeah, I was riding the struggle bus. I was using like clips as an editor, so I wasn't just like notepad plus plus or anything. But yeah, no, I was yeah.
Did you have a
All my
crew?
freebies were PDFs, and
Did you have a crew of other guys and gals around you doing coding, or were you solo?
Yeah, there were a couple people. So like we had like a CS class, and so there were like a couple people that I would like hang out with and basically like try and do stuff. I had one friend that like ended up making it was kind of a Minecraft-esque like 3D rendering thing that like I don't necessarily know how much he actually did of like the math stuff, because it's a lot of like linear algebra and stuff, but eventually he basically found like kind of like a tutorial on it, and then the thing that he did was he changed it so that the graphics would work in console. I just thought that was really cool. I was because he like basically modified all like the lines to like draw in console, so he had like rectangles and like moving. It's pretty cool.
Nice. Cool.
But,
So then how did you ultimately find your way to Cornell?
yeah, so kind of as I said, like my family was very Cornell oriented, and so it was it wasn't that long of pondering about where I was going to go, to be honest. Like basically Cornell is probably one of the most academic focused, or not academic, the most engineering focused of the kind of Ivy League colleges. And so we kind of all just like went through there. I spent a little bit of time thinking about like whether I wanted to go to MIT or kind of some of the other like higher ones, but I ended up only applying to Cornell, and luckily I got in, because otherwise I was pretty I was gonna be pretty roasted,
You're the
because
black sheep of the family.
well, it wasn't that. It was so at the time, and I think they've changed this now, but if you take like the SAT, there's like an optional writing component. And Cornell at the time was like the only of like the top schools that didn't require it. And so I was like, cool, I'm not gonna take it. And if I didn't get into Cornell, it would have been like a big issue, because it would have been after when I could take like the next like SAT with the writing. So it would have been rough, but it worked out. So I ended up getting into Cornell and going there. So
Were
yeah,
you were you super plugged in? Like when you showed up, did you live with your brothers, or like were you super plugged in when you showed up, or did you have to do your own thing?
so I just so at Cornell freshman year, they kind of have all the freshmen are in North Campus. So they kind of have housing set up for all incoming freshmen. I think it's required. I don't think you can get out of it. Maybe you can, but
no,
yeah. So I was there for freshman year, and there's this course which is like the honors like CS course, which is 2112. It's like honors object oriented programming data structures. So I ended up going and taking that class, which I was really lucky to be able to do that, because I was able to kind of make friends with some of the really good programmers, and I was able to kind of like get in with that crowd and go from there. So that was kind of how I kind of like, I feel like at that point that's when like coding got like really real for me, where I was like, all right, yeah, I'm like doing this like intensely now. Even though I was obviously enjoying it in high school, but once I was in college, it was different.
So then how did you ultimately come to, I know you said you went to Goon and just said, hey, I want to work with you, but so what was that? How did that play out?
Yeah, so Goon teaches a required, or Goon taught at the time a required class, which was operating systems, which is fitting considering our earlier conversation. And so I was taking operating systems with him, and I just kind of really liked his teaching style. Like he's very direct and like anyways. So I just kind of liked his teaching style. And at the time, I was very interested in distributed systems. So I had done an internship, and I was kind of working with like AWS cloud stuff, and I was just very interested in distributed computing at the time, and in distributed systems more in general. And so after that class, Goon was teaching introductions to cryptocurrencies and smart contracts, but with a focus on distributed systems. So focus on like, how does like Bitcoin actually work from like, a consensus mechanism, like how to like, all those things. And so that was, I basically liked, taking this class with him at the time. And then he seemingly was teaching a class that I would be very interested in. So I ended up joining with that. And I'd also, going back into high school, been slightly introduced to cryptocurrencies from my dad, actually.
Nice.
And so I was kind of aware of like the crypto space, but I certainly wasn't very involved with it.
How did he introduce you? Like, what does that mean? Your dad introduced you to crypto?
He was basically like, hey, you really like CS. I just like saw this Bitcoin thing. Like, I think you'd like it. That was
Very
like
cool.
basically the introduction. And so at first I was like, I don't even know like why, but I was kind of like, yeah, okay, like I'm working on like, whatever the stuff. Like it was not like I didn't even read the paper like for a little while. And then eventually I ended up kind of getting involved more with crypto in high school with like some statistics stuff, with like just kind of looking at like correlations between the different cryptos and just finding the space kind of more and more interesting. But not even necessarily from like the core based tech level. Just kind of more like interesting like phenomenon of like, oh, this is kind of weird. But yeah, so I was introduced to it kind of early on, and then I ended up taking that introductions to cryptocurrencies class with Goon, and then that's kind of where I became like, kind of more introduced to the pure tech side of it, which is what I was more interested in at the time, and now I'm like fully down, obviously, in the tech side of these systems. Yeah.
So had you read the white paper when you started the cryptocurrency class?
Yeah. So I like dug through it. I definitely didn't understand it, like, but I had like gone through. I was like, oh, this is kind of like interesting. And so I had like gone through it, but it hadn't like, I wasn't so immediately like taken by it that I was like, developing on Bitcoin Core or anything like, like, making pull requests. It was kind of like, oh, like that's interesting. But at the time, I didn't really know kind of the background technical knowledge to actually appreciate it,
Sure.
to be honest.
Yeah.
So yeah, so
I want to jump in here. So one of the questions I wanted to ask you, I write a lot of threads on Twitter trying to introduce people to developing on building applications on Avalanche and different like Ethereum smart contract based operating systems. I don't talk a lot about the platform side. And so now you're kind of talking about your journey and how you came in through this like cryptocurrency class. I know not everybody is going to have that opportunity to learn about consensus protocols. So like, what advice would you give somebody who is just starting out in their career or is interested in this and wants to learn about the platform side of building in the blockchain ecosystem?
Yeah, so it's really interesting, and this is kind of one of the reasons why I love this space, is there's so many different things that you could latch onto first. Like if you're interested in cryptography, right? There's a whole area of cryptography that's going on inside of like the crypto, like cryptocurrency bubble, I guess. And so like if you're interested in that, like that's definitely something you could latch onto, like dig in really on the VM level and like go from there. Also like networking, right? Like if you're interested in networking stuff, like all of the peer-to-peer networking gossiping that we're doing, like, all the handshake logic, there's a lot of stuff like you can kind of grab onto just with that. Kind of one layer up from the networking is like consensus protocols. Like one of my original interests was consensus protocols because I just felt like it was like one of the hardest things that like you could do in CS. It was like you have like these nodes, like you can't trust some of them if it's like a BFT, a Byzantine fault tolerant system. And so like, there's if you're looking for something really difficult, like, theoretical, like consensus related Byzantine agreement stuff is really nuanced and yeah, so that's like a really interesting problem in and of itself. There's also databases, like if you're interested in databases, like, so there's just so many different areas that you can like start on. Like my initial interest was in consensus. So like distributed systems and agreement and how nodes can like decide on things. And so that was kind of like my original like interest. And then it kind of blossomed into the rest of the space. So I guess like from my experience, I'd recommend like, if you're interested in, any of these, and of course, like that's, there's more than just, there's also like VMs, like, execution environment, stuff like that. But, if you're just interested in one of those things, right, like you can kind of take that interest and dig down into see how it's applied, and you'll, eventually you'll probably get, exposure to the rest of the ecosystem and the systems and all that logic. But yeah, so I would basically say like, if you have like one particular interest, kind of like dive deep into that and kind of go from there. I don't know if that's the best way forward,
no,
but
that's great.
at least what I did. So
that actually reminds me of something when I took a compilers class in college, and that was something that I thought was so cool because I thought it brought together every piece of my undergraduate curriculum kind of in one course, because you're using all the different data structures. You have to think about the architecture of the system that you're compiling down to. You have to know a little bit about like how programming languages work. And I thought it was just like a perfect capstone to like capture like every piece of my undergrad experience. And now that you're saying that, this is kind of like turning some light bulbs on for me that like blockchain is actually kind of the same thing, because no matter what part of like, if you're interested in like systems or programming languages or any of the like applications, like there's actually a place in crypto for you, because those all show up somewhere. Because like Ethereum, they like to call themselves the world computer or the global computer, right? And so any part of computing can be found within that global computer. If you're interested in programming languages or compilers, you could actually look at building different VM languages and compilers to the VMs. If you're interested in building non-distributed systems, you can build like the VM images themselves that can run on a platform like Avalanche. And all the other things. If you're interested in the distributed systems part, if you're interested in consensus, if you're interested in data storage, if you're interested in ASICs,
security.
Security. There's so much. So if you're ever wondering, I have a CS degree and I'm interested in this one thing, but I don't know about consensus algorithms, so I'm not a blockchain person. Like, I don't think that's actually the case at all. I think there's room for so many people in so many specialties.
Yeah, and there's go for it, Stephen.
I was just gonna say it was a great bringing in compilers as well, because Solidity, everyone knows Solidity, right? But I don't know if many people actually like Solidity, and so there's a lot of interesting work just to go in with that. I think Ethereum is looking into some Wasm based stuff, or at least they were at one point. But like developing out like a new kind of smart contract based languages. I think it's pretty important right now that we've seen, especially on Avalanche, that interoperability. So using like EVM bytecode is probably pretty important just for kind of getting people, because it's what they're used to right now. But definitely like compilers is a great additional to that, and a great course with Myers. That was definitely known as like the hardest. It was definitely known as the hardest class in CS at Cornell.
Really?
And it was a great class. 100% would recommend.
I took it my senior year, and it was at the same time as the wines course that all the seniors took, and I was just like, I've been looking forward to this for 4 years, this wines course, but
I think the the most succinct way of phrasing it, I think, that I heard was that if you walk into the compiler's lecture, you just see all of the CSTAs right there because they're all taking the class. Like, yeah, it was great.
So going back to whenever you joined Cornell, I wanted to get a sense of what was your your blink impression of Goon when you first met him. And I asked this just to give some color on that. Goon is a historical character, right? He stepped into the history books, in my opinion, and he's a living meme. And his work on Avalanche consensus is in fact going to have an impact for a long time to come. And so I wonder, what did you think when you first met him? What was your initial intuition?
I mean, my intuition was, that he's like a straight shooter, basically. Like he'll say it as it is, and that he really enjoys like not just the CS, but also kind of like teaching like people. And so as someone that was like interested in learning, I was like really excited with that. There's some professors that I'm not going to name any names for sure, but there are some professors that are definitely like there to do research and don't like teaching. And I don't necessarily know that Goon likes teaching or not, but he certainly like enjoys kind of having intellectual and stimulating conversations with students. So that was kind of all I needed to say, like, this guy's like a straight shooter. He'll tell me how it is, like, kind of no BS, which I really enjoyed and liked. And then also, he's willing to kind of talk with me and go back and forth and have like, interesting and meaningful conversations about something I was super interested in. So yeah, that was basically just kind of my first like vibe from him, just being like, all right, like I can talk with this guy and learn some stuff. And I was super excited about it.
Did he seem approachable to you? Did you feel like confident that you could just go and hit him up?
I mean, I don't know that I felt like any like professor at Cornell was like super approachable, but like,
Sure.
I don't know. Like,
so you went to him and you said, I want to work on something. And he said, have you heard of Avalanche? And handed you the white paper. Is that how it went down?
So basically what had happened was he said, when I was in the crypto like class, he had basically kind of hinted like, oh yeah, there's like kind of a new like consensus thing like happening. And I was like, well, that's interesting. And so then I went and I was going to a different internship, and literally I was driving to New York. I was riding. I wasn't driving. To New York City, and I was like on my phone, and I saw like the IPFS paper for Avalanche was like dropped, and I was like, oh, this is what he was talking about. This is cool. Like, yeah. So then basically after that internship, I went back and like said, hey, like I did a couple classes with you, like can I do research with you? And then he was like, yeah, like let's go. So that was kind of how that fleshed out. Yeah.
Okay, so a couple of thoughts that come out of this. Number one, was it challenging for you to finish your other internship having read that white paper? Like, did you feel, man, somebody else is making a move when I should be? And then number two, like, sounds like, yeah, go ahead.
So at the time, so as part of the crypto class, we did like there was a final project where you basically did something interesting. And so I don't know if you've ever heard about T-Chan or T-Chain, but T-Chan is basically a off-chain L2 for payments on Bitcoin using SGX hardware. And so for the extension to that, as my final project, me and a friend of mine ended up doing Tether, which was basically that for Ethereum.
Nice.
And so one of the cool things about Tether that was interesting was that you could like split up balances, whereas on Bitcoin, because of like UTXOs and stuff, it was a little bit more challenging, but you could like make a smart contract to kind of handle these receipts using just SGX. So that was, so I basically done that. I was like, oh, this is pretty cool. But there was another project that did something else in SGX, and I don't know that I can talk too much about what it was, but I was basically so inspired on that I started implementing a different, like my own version of that over the summer, like after work. Like I would like my internship was at Google, and so I would like get home from Google, and then I'd be like, all right, like time to work on this thing. And so I actually spent a while working on that. So I wasn't out of the game from like a crypto perspective. Like I was definitely plugged in with that, but I was a little bit sad that I wasn't working on the Avalanche at the time. Yeah.
Did you almost end up at Google?
Like no, in like concise terms. So I was there for an internship, and I definitely like at the time I was a sophomore at the time, so I wasn't looking for like a full-time thing, and so I wasn't really thinking further ahead on like whether or not I would like on like what I would be doing that far out. And so I ended up like, you know, going back into like their pools for doing like another semester, or sorry, another internship the next year. But at that point in time, I was basically full-time Avalanche. So like by the time there was any questions about whether or not I would be working at Google, I was already like fully wired in on Avalanche. So
you not only worked on Avalanche, you also graduated early. So
yeah.
So when was that always the plan, or was that something where
No.
like, you were working on Avalanche and you're just like, shit, this is like taking off, and I just need to get done with school so I can work more time on this?
So my original plan was I was going to do a double major of CS and ECE, electrical engineering, and
that sounds easy.
And yeah, and then I took like my first like ECE class, and I was like, yeah, you know, I'm not that into this actually, like not as excited as I thought I was going to be. And so then it turned into well, I'll do like CS and then maybe like a math minor or something. And then that turned into CS and then like a master's. And then it was like, you know, I'm working on Avalanche, and like if I like take a lot of credits this semester, I could just graduate now with just CS, call it a day. Like and so I basically just like kind of loaded up with a couple additional credits for my last semester, and then just graduated, and then just went full into at the time when I graduated, I don't even know, I think it was around when I graduated is when Ava Labs became a company, and so I basically just went into that.
How did you actually like sleep? Because that just sounds
I
like
didn't.
that last
It was-
year.
My last semester was brutal. So Aaron Buchwald, who's kind of very critical in the core ETH C chain development. He's also he's a full-time student. So he was a student as well, so he understands like my pain. But I only had to do it for one semester. He's been doing it for a little longer than I had to. But yeah, my last semester was really brutal. To be perfectly honest, like yeah, it was rough. I definitely remember like I was basically going on like 4 hours of sleep, which I'm not a 4 hour sleep kind of guy. Some people can do that. I'm not. So I'd basically do like 4 hours of sleep, and then like, you know, every like 6 days or something, I would just crash for like 10 hours, and then I'd be like back up, and then I just like back on the 4 hour sleep schedule. It was like super not healthy. My last semester was really brutal, but
and what do you obviously this is relatively personal, so feel free to dip it, but what do your parents think? You know, your mom was super in education, they're very Cornell centric, your dad turned you on to Bitcoin. How do they feel like where you're at right now?
I mean, they're super stoked. So
Do they
basically
understand
like,
it at all?
like the
I have
technical
a
details?
lot of
Like,
experience where my parents are like, yeah, Connor does something with computers.
yeah, I know.
Yeah.
It's similar to that. Like they're definitely not CS, you know, people. But yeah, no, like definitely like my parents are like, hey, like if you like it, like cool, good for you. So
Yeah.
yeah, they're definitely not like judgy on kind of like what I spend my time on. Like if I'm into it, and you know, I'm not like doing something like
Distributed
anyways.
systems. We're a centralized operating system family.
Exactly. Yeah.
You're
yeah.
out.
Yeah, definitely nothing like that for sure. Yeah.
Okay, so let's circle to AvalancheGo, because
Yeah.
context, AvalancheGo is the main client in the ecosystem. There was some work that was done on a Python one. It never got across the finish line, though a ton of energy was dedicated to it. It could probably still be resurrected if somebody were totally motivated. A lot of great work there. I know of somebody who's been working on a Rust client, but I'm sure 100% of the clients out there are AvalancheGo. To me, it's an incredibly important piece of software. I mean, think of all of the stuff that's going on, and that's really your baby. So let's talk about how that started, and let's talk about that journey.
Yeah, so I kind of already talked a little bit about how the language was picked. Basically just going to Goon, and he said either pick Go or Rust. But yeah, so I started that during my last semester. So that was when I had like no sleep, and the reason I had no sleep was because I was basically working on AvalancheGo full time, and so yeah, there was just a lot of like interesting problems. Like for example, with just like the voting mechanism, how to do that efficiently. And so what you end up doing, right, is you end up like polling K people, but they might give you kind of different frontiers on this DAG, and you have to find like which transactions received alpha votes. And so just like the algorithm for calculating which transactions actually received that is like, it's non-trivial, right? Like in the worst case, it's like, O of the number of like vertices multiplied by the number of people you poll is kind of like the worst case thing that you could deal with. And just like, how do we make that a little bit more efficient? And so we end up using like bit sets to like make like unioning faster, so that like to get the O of K out to be like constant time. And like, there's a lot of different like challenges that came up, and a lot of like fun different like things to fix there. But originally Goon actually, so Ted actually made the very first client. So Ted worked on some of the like he worked on like a C++ client that was used in some of the original benchmarks.
Okay.
And so
does that still exist? Do you know? Is that code still somewhere?
Probably that was like codename Chameleon, because originally it was like the Gecko, Mamba, and Chameleon. And so that was kind of how that originally started. And so I was basing a lot of kind of the very first pass off of the consensus off of that. And then Goon had also done a little bit of work, which then was spun out into the Mamba client. Gotcha. And so I was basically originally taking those two as kind of like some ideas and references to base off of kind of what was the Go code base. But because Goon was a full-time professor at the time, and Ted was kind of doing his own additional work as well, pretty soon after that, Go was kind of past those. And so from that point on, I was doing a lot of whiteboard conversations with various different people and kind of fleshing things out on how to go from there.
So yeah. was this something where like, was there always the plan to be just like a singular client? Or because I know Ethereum, they were very definitely much not like, we have to have like 5 clients. And I know they kind of like bit off more than they could chew at times, and kind of had to scope down a little bit. Were we the same?
Definitely not. So we definitely wanted and still want to have multiple clients. There's a lot of good reasons to have multiple clients. And so we definitely want to kind of diversify out with that, which is why we spent and so when Gabriel said earlier that the Mamba client was like kind of like put on hold, it was put on hold very late.
Mamba is the Python client, just for clarity. That's the Python client.
Yeah. My apologies. Yeah. So the Python client, there was active development working on the Python client until like probably like a month or two before mainnet launched.
Wow.
So there was it's a very it's very actively like it's not very far away from being a working client. we just haven't had kind of the ability to give it the love it needs, because essentially what was happening was, we were making some key decisions at the time and putting those into AvalancheGo and running with it because we were trying to get like mainnet kind of ready. And what was happening is, like, if we found like, oh, we need to like change, this thing because of some weird edge case, like that would end up cascading into Mamba. And it was just very difficult for us, just with the timelines that we were kind of working on, to be developing to clients. And so we said, okay, like we need to put this on hold and focus on AvalancheGo. And so we've done that. But I definitely think that there's plans in the future to revive the Python client. But yeah, so absolutely, we definitely would love multiple clients. So
Gabriel probably knows a little bit about that, like Mamba experience, because it just sounds like whenever there's an AvalancheGo change, that always has trickle down effects into AvalancheJS. And I just see him on Slack all the time being like, how does this affect us? Like,
plus Goon and Kevin asked me to kind of help get the Python code base across the finish line. And there basically, like he's saying, there was just too much churn on the AvalancheGo side, and the Python side was understaffed. And so there just wasn't the ability to keep up with it. But it is very close. Like it ran, you could do RPC calls. I'd say at this point, due to codec changes and stuff, you probably couldn't do transactions, but it was extremely close. And
it'll certainly like connect to like AvalancheGo and do things like that. So it's pretty far down, like it has all the consensus stuff implemented, and yeah.
So am I correct in, so the analogy I always use, and sometimes people are like, that's a bad analogy, but it's just the way I think about things because I'm a web developer. So to me, there was Netscape Navigator and Internet Explorer, and there was no standards body. So there was a world of kind of two different, you had to write a website twice, and you had to put a little banner on your site that says it runs best in Netscape 4 or whatever. And then ultimately Netscape died and became resurrected as Firefox. Internet Explorer 6 had like 99% of the market share. And then Tim Berners-Lee and the W3C with the HTML5 working group and the WHAT working group basically created web standards. And today we live in a world where, we have Chrome and Firefox and Internet Explorer and Edge and Opera and all of these different browsers. And Brave deserves a shout out. And because we have this heterogeneous network of all these different clients, we're able to suss out edge cases in the specification. Is that the benefit of having multiple clients?
Well, so certainly, yes. Like having clients is great for finding bugs in edge cases. But also just, in the case, and a great example is what happened to the Avalanche network a few months ago with the kind of invalid mint on the C chain. So that was a bug, not with the specification, but with AvalancheGo. There was a caching issue, and that ended up, the reason those transactions ended up getting accepted was because that bug was on, like that bug had happened on more than alpha% of the network, and so there was a series of transactions that got through because of that. If we had a multiple clients, then that might not have happened, right? Like it might have happened, like it still may have been an issue, may have caused a problem, but maybe those transactions wouldn't have actually been accepted because the Python clients would have said, no, this is invalid, like what's happening, And so like it helps with resilience and fault tolerantness, and not just for like finding bugs in edge cases, but also like preventing like bugs from impacting like live networks. So
gotcha. Okay. Yeah. So somebody asked, that was one of the questions somebody wanted us to ask you is, what's the guarantee that the same bug that happened in Q1 won't happen on a custom subnet? I don't know that there's any guarantees, but do you have any thoughts on that?
So nothing can be guaranteed, right? Like there's always bugs and things. At the time, we were basically, kind of fresh out on a mainnet. And so like from that perspective, it was still kind of wet paint code. And so we've since, and some people might notice that like the frequency of kind of new additions has decreased on AvalancheGo recently. And it's not because we're not working, it's because we spent a lot of time like just like fleshing out, making sure everything's rock solid, secure. And so that's been like a major focus for the past couple months, is just, hardening, making sure that we have everything that we need, so that we feel good about that. Because that was really kind of a big wake up call for us to say like, whoa, like that should never happen. And so we spent a lot of time with that. And now that kind of we've had that time, like we're starting to transition more, hopefully, into kind of more additive features now that we have a lot more confidence in our base. Yeah.
There's definitely been a lot of talk in the community about this kind of like time period of Avalanche's history, because I think there were a lot of changes that weren't all necessarily communicated to the public in a big way, because we were kind of targeting that apricot switch over right around that time. And then we kind of went into the bug, and we really kind of reprioritized what was important to us at the time. And we kind of switched from having like one monolithic hard fork with a million giant network altering changes to instead saying, we're going to switch that back. We're going to focus on shoring up the fundamentals of the platform before we start introducing all of these potentially breaking changes, and really shore that up. And then switching from the monolithic release to a phased approach. So we use the language like apricot phase 1, phase 2, or whatever, and then eventually we'll get to blueberry for the next batch of upgrades. But yeah, so that was really, really insightful answer. But I do want to give a shout out to Twitter user Mojdetko, who was the person who submitted that that question. And if you would like to be a part of the show, you can tweet me DAS_CONNOR DOS Connor or Gabriel CG Cardona, and send us your questions for our guests, or questions you want to topics you want to hear about on the show, and we will try to answer them. And we do have some more listener questions to get to.
Yeah. So okay, so then let's kind of get to Ava Labs now. So you've been working on AvalancheGo, you're at Cornell. What was the actual transition to being an employee at Ava Labs? How did that go down?
Yeah, so I mean, my last semester I basically worked full time working on AvalancheGo, and once the company was kind of incorporated, it was like it wasn't even really a question. It was just kind of like, all right, yeah, here's a contract. Like it was more like that. It was more just like, yeah, like definitely we're all in on this, and like we're all working. So yeah, I think Amani technically signed her contract before me, but she only signed as a part-time employee. So I do have the exclusive title as being the first full-time employee.
That's legendary, dude.
Yeah. So
do you consider this your first job? Do you consider this your first job?
Yeah, for sure. Like, I mean, my internships were like jobs per se, but definitely not. This is definitely like my first like full-time thing.
Yeah, I hope you appreciate like the epicness of that. I hope you can like detach and step back and just say that's pretty cool. My first job is the first employee of Labs. Well,
if we want to talk about stuff like that, so my first Go program is AvalancheGo. So.
Wow. Yeah, not a bad start. Okay, yeah, so
as a side note, so if anyone's looking through particularly old parts of AvalancheGo and they're like, man, can we swear on this? If this is really bad code, that I'm sorry, it's my first Go program. But yeah, so yeah.
Okay, so then now you've joined Ava Labs, and as I perceive it, having especially been in the industry for quite a while and just being a professional for quite a while, things move very, very fast. We've been successful, we've had some ups, we've had some downs, but what do you think, what is like the good, the bad, and the ugly of our journey so far?
So, I mean, I think the thing that's kind of kept us all together the whole time is that we're very like academics first, like we're gonna like principles first kind of like path, right? So there's definitely like some like, again, not naming any names, but there's definitely some cryptos out there that'll just kind of like have some idea and like it doesn't really make a lot of sense, but like there's some vein of like, oh, that's kind of interesting, and they'll just kind of like yeet it into existence. Whereas for us, like we've always kind of said like, okay, like, it's very principled, like, all right, how are we exactly going to do this? Like, how does this all like fit together? And we kind of like make sure that, everything makes sense from an academic perspective. And so that, you can see just by like the release of the Avalanche or the Avalanche paper, like as being like the base of kind of what we're doing, like that is kind of what started it all. And then like, that's kind of the academic source, right? And we're trying to upkeep that. We haven't been releasing as many papers as we might like, but that's also just kind of like we still do a lot of that work, but we don't end up necessarily publishing it because actually putting a paper together is a lot of
time spent writing is time that could be spent coding.
It's true.
But,
we are at that place in the chapter of Ava Labs where we're still a startup, although we're growing fast. And so, like somebody like Stephen, who would be writing a white paper on a new type of consensus, is actually implementing that new type of consensus, basically.
Yeah,
So,
I mean, if you just look at Snowman's a great example. Like, there is not a paper necessarily talking about Snowman, but like the principles all come from Avalanche, and it's not too difficult of a transformation, but we just haven't had time to really put the pencil to paper on that. Yeah,
I want to give us a knock for that. I think that's something that I've seen a lot in the community, is that we talk about Snowman a lot, and if you're just trying to get a grasp on like, what is this, like, you can find out that it's the linear blockchain version of the the more DAG native Avalanche consensus. But yeah, beyond that, it's like pretty hard to get some details on that. So I will say we could do better as a company. So I'll make sure to send you a task on that.
we'll sign you some tickets in Jira, man.
Yeah. I have a couple extensive Discord posts if you dig far enough. So maybe that can be the start of the paper. But yeah. Actually, so I say that the paper has definitely been started. It just hasn't been touched in a while. Yeah. So yeah.
And do we have any other? Are you doing any other work on other consensus stuff right now that you can talk about?
So I haven't touched this in a while, but I've been kind of developing just some nothing. Well, okay, yes, company wise, but also just like side project wise. I spent a lot of time in my free time, whatever, developing like some in Rust, just developing some of like some fully asynchronous consensus protocols. So I have a couple like of the OG ones implemented. So I have like Ben Orr consensus, Gabe Braca, like 1/3 BFT fault tolerant consensus. I also have Bosco implemented, which is a modifier on those, and just kind of some stuff that I've done in my free time as I'm kind of interested in that. But so that's stuff that I can talk about. So I have worked on that
Sure.
kind of in my free time. But
because you do have this academic background, when you're sitting on the beach sipping your Mai Tais with your millions, are you ever thinking about going to grad school or getting that PhD? Is that something, once all this Avalanche stuff is behind you?
So that was definitely when I said the plan was, dual major and then major minor, major masters, there was another one after that, which is graduate and then PhD. And so I actually did apply to Cornell, and I kind of wanted to work under Goon for my PhD. And I've basically deferred that for 3 years. So I've been kicking that can down the line year after year. So it's definitely possible. At this point in time, I don't know how likely it is, to be perfectly honest, of me going back. But yeah, it was definitely a strong consideration for sure.
Yeah. So then, to go back to my initial question, and maybe you've already answered and we can move on, but what are some of what do you consider our greatest accomplishments, and what do you maybe consider not, what would you redo if you could do differently? I know one that comes to mind immediately is something I've harped on 1,000 times, and Stephen, I've harped on it to Stephen 1,000 times, is our CB58. So basically we have a base 58 encoding we call CB58. Base 58 check is this famous encoding that comes from Bitcoin. And Ours is CB58, and the difference is that we only SHA-256 once, and we use the first 4 bytes as the checksum instead of the last 4, or vice versa. And I remember I asked Stephen about this, and there's a reasonable answer, and basically is that it mirrors what we do in our signatures, but then that makes me wonder, why did we do that in our signatures? So that's something that I've wondered about multiple times.
Yeah, so in Bitcoin, signatures, they sign using a double SHA, and that's to prevent, I believe, someone might correct me. But anyways, in general, Bitcoin, as far as I'm aware, uses double SHAs, which prevents link extension attacks, which is essentially that what you can do is, given a hash with a SHA-256, what you can do is you can actually calculate like pre-image plus some value. Like you can, it's not super important or relevant, but it's things that can happen. And so I think Satoshi, whoever they are, came from a very principled like crypto background, and so they just out of principle used double SHAs, and it's really not necessary for what we're doing, to be perfectly honest, because we're signing the hash. Like it doesn't matter. Like the pre-image is already known, so it's not like weird that you can calculate like a hash without actually knowing the pre-image. Like it doesn't matter. And so we essentially just didn't do that because it was just an additional hash required during signature verification. And so we didn't do that. And so it kind of just fed into, well, when we're doing this like API checksum layer, like we'll just do one SHA, whatever, it doesn't matter. Which looking back, as I mentioned kind of earlier on, like using tools or like being compatible with existing tooling is something that we definitely understand now and are very like happy about kind of the approaches that we took with the C chain for that. But it's probably something that I didn't necessarily respect as much as I should have when I was first implementing AvalancheGo. So
yeah, that's something that's tripped up a lot of partner integrations. I've had many conversations where they're like, "What's up with your base 58 check?" And I'm like, "No, that's CB58, my friend. That's not base."
But yeah, no. So yeah, there's like definitely some things kind of like that. There's another thing, like for example, our networking layer uses kind of like these fixed encoding, or like our custom encoding that we use for transactions. And the reason why was because at the time, we had to encode transactions and we wanted it to be in like a canonical format. And so we looked around at a bunch of different serialization primitives, and none of them really gave what we exactly wanted. Like I think Cosmos has recently switched to protobuf, but protobuf is a little weird because it uses varants and it doesn't actually enforce that, like, things are canonically encoded. So it's like a little weird and like ordering stuff. So we ended up like using our own like kind of custom like format for the transactions, which is what we still use. And honestly, I think that makes a lot of sense. But we use that encoding also for our networking layer, which at the time made sense because it's like, yeah, well, I have multiple encoding types. But if you don't need that canonical enforcement, it's really nice to use something more like flexible, like protobuf, and it'd be a lot easier to integrate and things like that. So that's something that we could still change, but it's just kind of a pain to do. So there's like things like that I kind of wish were a little bit more flexible.
I know of another one. I've mentioned this to Stephen. And of course,
don't know of too many. Like,
yeah. No, he had an answer for this one as well. So our blockchain IDs are unique in a global sense. They're not unique per subnet. So in other words, in theory, if I created 2 blockchains across 2 different subnets, in theory, they could collide. Obviously, the numbers are astronomical and it's unlikely, but in theory, the same blockchain ID is not sort of like namespaced to a subnet ID. And if I remember correctly, like, am I correct? Am I thinking here, right? That is correct?
Yeah, I mean, it's a hash collision. So
where I was going with this is basically, I remember at the time I had said, I was thinking about it like a relational database, right? So I was thinking like one subnet has many blockchains, one blockchain ID belongs to a subnet, right? And so in theory, you could have the same one across multiple subnets and they would not collide. And at the time I had said something like, and this isn't taking into account the birthday problem or whatever, the numbers are going to be wonky here, but whatever we're getting now, 2 to the 32 or whatever the number is, right? Some number, we would get like that many more if we made each subnet, each blockchain ID unique per subnet. And at the time, I think you had told me there is a solution there, and that's to use like a 512 byte hash or something. There would be a solution if we ultimately wanted to do that. I don't know if that conversation, if you remember that conversation at all.
I have no recollection of this conversation.
Because see, the way I'm approaching it is this. Like, to me, I think whenever we had the conversation, and I wish I knew the numbers right now a little bit better because I might not pack as much punch. But what I was saying is the difference between having the blockchain IDs be global as opposed to be nested between the subnet IDs is some absolutely mind-numbingly astronomically more blockchain IDs that we would be able to have. And at the time, I think you were like, dude, it's like 2 to the 128 or something. That's plenty. So, you know, like you were like, we ain't gonna. Go ahead.
Yeah. So blockchain IDs are 2 to the 256, which.
But then there's a birthday. There's a birthday problem. In theory, there would be about half of that before we collide, right?
I mean, square root of the like 2 to the 256 is a pretty large number.
Yeah,
still.
Right. So like, see that. But let me finish my thought. So that's the exact conversation we had before. It's like, dude, 2 to whatever is pretty damn big. But see, man, I'm thinking about it a little bit differently. I'm extrapolating like 100 years out, and I'm thinking like super strong AI or something like that. There are going to be like chewing through those types of numbers may not be big in the future. It may be big to us relatively now, but it may not be. Go ahead.
I'll put a more concerning thing. How about, so if this is an issue, so I don't think this is a particularly concerning issue, but if it is, I think what's probably would be more fun is what you could do is you could create the Bitcoin blockchain. It could be a cycle, so you just go round and around, because essentially if you have like a parent ID, right, like you can just end up making it so that now that parent is like pointing to your own thing, because that's a hash collision, right? And it uses the same like SHA-256, right? So it's the odds of someone producing a new block that is actually like the same hash as an older block, and then like those blocks end up kind of like forming like a circle. So I'm not super concerned about that. I think recently, so this is a little scary that this is actually even becoming a conversation, which means like there might need to be a time where these hashes are bumped out. But I think, so in Ethereum, the address space, similar to in Bitcoin and here, is 160 bits. So rather than 32 bytes, it's 20 bytes. And so there's some conversations going on right now in the ETH space about, well, what if someone were to grind such that there's a hash collision on that 160-bit space, such that someone can create a private key that actually has the same address as a smart contract, so that then they like take the money away from that smart contract. And they did the math out, and apparently right now, if someone were to try to do that, it would take about 1 year of Bitcoin mining to attempt to do that, which they did some back of the napkin calculations is $10 billion. So these things are,
it's approachable.
So 160-bit is definitely like on the orders of like that might be concerning in like the near-ish term. I would say 256 is still pretty far out. I don't know if there's any weaknesses that have been found with SHA-256 yet to like bring that like number down. I'm not aware of any, but I wouldn't be surprised if there are some kind of things that have been found. But anyways, so 2 to the 256 is still a lot more than 2 to the 160. But certainly like hash functions that are 512 bits are kind of becoming more prevalent now, and so especially like so it is a valid concern to think about these things, and I think that if we were to get into a space that we're more concerned about that, then we could probably change the block hashes to be instead of SHA-256 use like some more secure hashing functions. But
Yeah. So I kind of wanted to dig into this a little more, not necessarily this, but I want to talk about how platform L1, layer 0 development is changing in crypto, and kind of like what you see the future being. And so you've been in the game for several years already. Ethereum has come out. That was, the first big revolution moving from Bitcoin. Now Avalanche is really a revolution as a layer 0 protocol, but we're not the only ones. There's also kind of Cosmos, Polkadot, who are kind of doing to do similar network of network effects. We also have Ethereum experimenting with things like sharding, and proof of stake is already very well here, but we're starting to see roll ups, layer 2s. So I guess what do you see as the big innovations in the platform space in the next couple of years?
So this kind of touches in with the fact that there's like so many different things that are interesting happening. Is there's a lot of different innovations happening at different levels, right? So if you just look at like the data storage side, there's a lot of interesting things happening with regards to kind of more stateless VMs. And again, like in the Ethereum community, there's been a lot of talk about like, well, how can we like have a more stateless VM? So I think like that's very interesting. I also think that like databases in general, there's a lot of room for improvement. I am thinking of something in particular, but I think Goon would be mad if I brought it up. So I'm not going to say that. But anyways, I think databases in general, there's room for improvement. We have internally working on like a CedrusDB, which is a more optimized storage for databases or for like blockchain.
Which, by the way, just real quick, somebody did ask about that. I don't know if you're able to give any insight. I know that we were going to grill Ted on it whenever he's on the show, but I don't know if you can, and I'll even light dive there, or if you just want to move on. But yeah, somebody did ask specifically about Cedrus and if you know anything about it.
So we integrated Cedrus into AvalancheGo. And the one major drawback that Cedrus has is that it doesn't support database iterators. And so we actually went through and removed iteration from all of like AvalancheGo. But right when we were like about to like actually add support for it, there was some dependencies that were added into Core ETH that heavily rely on iterators. So we essentially were like just about ready to roll it. And then we had to kind of put a stop gap on that. There's still like, we could still add it in. It's just a little bit more nuanced. So from that perspective, like, yeah, Cedrus is definitely an improvement. And we played around with it and we saw some really nice numbers on it. But we would essentially have to do some non-trivial updates to the database structure to kind of reintegrate it. So that's basically the status of CedrusDB as far as it goes with AvalancheGo.
Gotcha. I didn't mean to sidetrack from Connor's question.
No, yeah. But yeah, going back to Connor's question about like what was it? It was like future development and like layer zeros and how it's fleshing out. Like I think that I'm gonna bias this question just based off of my interests, right? So I think like if you, as you kind of mentioned, right, like Ethereum is working on the sharding thing, and a lot of other cryptos are working on that. Like if you look at like Polkadot, like they have their kind of like their mechanism, and Cosmos is more similar to us with like having multiple different like zones or whatever. But I think that I'm very interested to see with how sharding goes. I know, so I worked with so one of my friends at college worked on a BFT sharding protocol at Cornell, and they implemented this whole thing, and essentially then they benchmarked it and they basically just shelved it. They were like, okay, doesn't work. Because essentially they just ended up having issues with cross-shard communication, and it wasn't a performance increase. It was actually slower than just kind of naive BFT implementations. So I'm very interested kind of in how those flesh out. And I know like you can definitely like get performance increases by like using synchrony bounds and things like that. And I'm sure that a Ethereum dev that is focused on ETH 2.0 could come in and school me about, oh, this is how it's, this is how it works, and this, but I just want to see it. I'm very interested in that, and like if that ends up working and comes out of that, I'm super interested in that. And if I'm also super interested in additional like zero knowledge kind of crypto tricks. That's a very interesting area because it's like the most like bleeding edge stuff in the space right now. Like it's very rare when you can have systems that are like live and in production worth billions of dollars, where like the cryptographic primitives that they're based off of were like developed like 3 years ago. And it's like what, like this stuff, it's wild, like the innovation that's happening there, like
it is really crazy. I did not think, I'm not that old, but like it seems like in the first like 20 odd years of my life, there weren't any like huge leaps in cryptography of like, okay, we gradually started to move to higher key size algorithms. We moved away from like DES to like triple DES and like AES and stuff like that. But like where we are right now with like homomorphic encryption and snarks is just crazy. Like crazy. And like this stuff barely works. Like I worked with some homomorphic encryption and some verifiable computation stuff last year, and like the people who invented it like wrote a library, and like it's like terrible like researcher code, and like that's like the bleeding edge homomorphic, but it kind of works now, and it's like kind of performant.
I mean, when I first heard about like homomorphic encryption, it was like well, we don't know that fully homomorphic encryption doesn't exist. It's like, okay, like kind of cool. And now it's like, everywhere, right? With these like logic circuits that like, it's crazy. So, so I think that as time goes on, like, the space is going to be following the research always, in my opinion. And I think like the hottest areas of research right now are in crypto, like things like that, along with consensus is honestly not there really isn't that much stuff going on with consensus anymore. For the most part, like classical protocols, like hot stuff was kind of the okay, this kind of checks a lot of boxes of what people want, which is of course what like Facebook's Libra adopted. And it's very similar to Tendermint, except it solves basically like a live lock issue. They have like a synchrony bound. And anyways, so
one thing you made me realize real quick, I just think this is kind of interesting, is like for the last, since like World War II, I mean, maybe even before then, like every cryptographer like worth their salt, like in the United States, went to the NSA. Like that was the hotbed of like every like kind of like cryptographic innovation. Like that's where you went. You worked for classified government projects, or like some people went to go be professors of MIT. And from what I have heard is that the public crypto space severely lags the classified crypto space. So it's actually kind of cool that cryptocurrency is providing a kind of alternative place to go, so that some of that innovation can actually be captured by the public now, because I'm sure you can probably make a lot more money working at like some of these places, like doing actually some of this like ZK snark innovation and stuff, where that used to just be really kind of in the realm of a few like elite universities and the secret public sector. But now that's going to be like way more democratized and just have much higher incentives for people to contribute in the public domain, which is, I guess, really cool to see going forward.
Right, and
Yeah.
the difference in the impact that it'll have on society, right? Because usually if it's going to be developed in-house at the government, not always, I don't want to paint with too broad of a brushstroke, but it might be weaponized against the public, as opposed to if it's released as an open source hot new cryptocurrency, it's going to be very empowering to the public and the people around the world. So
yeah, it's very, go ahead.
No, go.
Well, I was basically just going to piggyback on, with all these things kind of happening in the open right now, regulation is freaking out, right? Because, especially with all this crypto stuff, like you can't ban it because it's just math, but at the same time, like it can be used for such positive and negative things that, it's really interesting. And I'm definitely not a lawyer. And so I'm basically sitting back with a bunch of popcorn being like, I wonder how this is going to go. Like, because it's just very interesting, kind of. Yeah, it's just very.
It feels like we're back where crypto was a munition, right? In the 90s, it was literally a munition, and you couldn't ship it over the physical borders, right? But then, of course, it went mainstream, and now it feels like we're kind of back at that place again, where the power structures are like, damn, this is asymmetrically empowering to people. Like, we kind of got to get our minds around this, and it's all moving so quick. And then now you sprinkle big money in there, just big, fast money. Before it was just like academic cryptography and maybe dissidents or journalists or somebody were using it. But now we've got big, fast money in the crypto space, and that changes the game much, much more. So, yeah. You touched on something there. Again, it was such a rich question of Connor's. I don't want to steer away from it. Is there anything else? The next question is basically, what virtual machine or subnet would you want to build? And the thing I wanted you to touch on is, what would a proof of work virtual machine or subnet look like in Avalanche? But before we go there, if there's anything else you wanted to touch on to wrap up Connor's question.
Yeah, so I think that actually segues pretty well, because I think that a lot of these things are innovations in Avalanche, in the Avalanche network at the VM level. And so all these kind of cryptographic additions and things like that can fit in really nicely in the VM space, right? So I typically use the example of Monero, right? Like Monero is a fork of Bitcoin at some point, I believe. And they do proof of work to get consensus. But at the end of the day, their key innovation is the bulletproofs and shielded transactions and stuff. And so that's kind of interesting, because if they don't care about the consensus, but they kind of have to deal with it, in more of an Avalanche network, you just have to implement the VM, and kind of the consensus is fully abstracted away. So I'm really interested at the future innovations at the VM level. And I think we're probably going to start to see kind of a transition to focusing on that kind of stuff. So to build off of your question, Gabriel, on the VMs that I'm looking forward to being implemented, I'm really looking forward to a stateless VM getting implemented, like a Turing complete stateless VM. I don't know.
You've said that 3 times so far. What is there one out there that you can point to? What is it?
What does that mean? Could you explain the concept a little bit?
Yeah. So imagine, and so this is one suggestion that I've heard, is essentially imagine the state of the blockchain is a single Merkle root, and the block contains in it, say some transactions that consume some state and produce some new state. And then in order to prove those transactions correct, that block also includes the Merkle proofs for the state that's being changed. So with just that, you could then generate the new Merkle root and move forward. So now all of a sudden, your validators don't actually have to keep the entire Merkle tree, the entire state of the network on disk or whatever. They just have to be able to process these blocks and move forward, and vote on them. And so now all of a sudden, this state growth problem that people are so concerned about can actually get pulled away from the validators, and it's not as much of a concern. Now, you do still run into issues of, well, how am I generating these blocks, right? And who is issuing these transactions? How do they know the state? And so I'm not saying that necessarily this fixes everything, right? It's not the the magical key, but I'm very interested in that, and I think that would solve a lot of issues for a lot of nodes. Maybe you still have some archival nodes in the network that act as data sources, but now you aren't requiring every node on the network to require that. So that's one thing that I would be very interested in. Additionally, we've already talked a lot about it, but I'd be super pumped if someone implemented a zero knowledge VM that's compatible with like the Snowman interface to be able to run like shielded transactions. That would just be super cool because I'm a big fan of that stuff.
Would that
So
be
those
possible?
are 2 areas.
Would that be possible as a feature extension, or does this need to be a full-on? Can the AVM add any type of privacy, or there's always going to be some type of leakage simply because you're going to be paying the fees in AVAX, and the AVAX themselves are not going to be shielded in any way? But could you add any ZK snark or privacy functionality to the AVM?
So the AVM is generic enough that you definitely can. It definitely depends on the crypto that you're using, on how like much like security you would actually, or like how much privacy you would actually gain from that. And
Sure.
but yeah, you definitely could. So in the AVM, there's 2 different like kind of ways that transactions can be issued. There's this thing called there's the standard like UTXO input output, and then there's also operations. So we use operations for the NFTs on the exchange, for example, and also for like minting new tokens. If you use a variable cap asset, it uses operations. And an operation is essentially something that consumes UTXOs and produces UTXOs, but the actual definition of what transformation is happening is up to like a feature extension. So that is very like opaque. Like you could implement anything that you wanted as an operation on the AVM, and as long as you're consuming inputs and outputs, that's fine. And so one thing you could do is like not only with shielded transactions, you could also implement that stateless VM that I described before. You could implement that as an operation where you consume a UTXO, which is the current Merkle root, and then you produce a new Merkle root, and the operation that happens is whatever like the previous block was. So like definitely you can do arbitrarily complex things in the AVM because of that. And then there's also a standard flow check where you have inputs and outputs, and essentially you just make sure that like you have at least as many inputs as outputs. And the combination of those 2 is essentially how you can transfer funds from one feature extension to another, which is the kind of interesting interplay between those. But yeah.
So piggybacking off that answer, I want to get to one more question on from Twitter. So CryptoPup asks, what open problems or research questions, if solved, would have a big impact on our end user and our dev experience? Are there any problems that have been solved academically but lack a good implementation by real world blockchain systems? So I think you touched on that a bit with like kind of like your stateless VMs and stuff like that. But I guess, is there anything else you want to add?
Yeah, so yeah, I think that there's a lot of work being done currently with just state management on these, because at the end of the day, consensus is state replication. And so, early on, people are like, wow, this is so cool. We can get everyone to agree on one global ledger or like one world computer. And now people are like, holy crap, like there's a lot of data that goes into one global ledger or one like, and so now it's, there's really interesting designs on, well, how do we like have the security of one global ledger, but like not require everyone to actually have it, so I'm very interested in state management problems. Tyler, who's a platform engineer working with us, is also like, I've had great conversations with him talking about different things regarding that. And so I know like I have a kindred spirit there with that. But so
and if anybody's paying attention, sorry to cut you off, Tyler agreed yesterday he's going to come on in the next couple of weeks and talk about Sherpa Cash and bring on one of the Sherpa Cash team members as well. Go ahead, Steve.
Awesome. You'll have to talk to him about state bloat and that kind of stuff. But yeah, so I'm very excited about that kind of stuff, and it feels like a solvable problem. Like it doesn't sound that difficult, and so sorry. It's difficult to get right, but it also is something that I am confident that we could implement like an MVP for, right? But to make it so that it actually like works well, flows well, like it really achieves what we want is probably a little bit more difficult. So that's something that I'm super interested in kind of like taking on more and working on that. And then additionally, this like fully homomorphic encryption stuff, it's super slow. Like even though like we've seen like tremendous like improvements to it, it's still incredibly slow. And so as that gets faster and faster, I'm very interested to see kind of how that ends up impacting the space. So I don't necessarily know that this is answering the question of like, if this is solved, then like we're gonna be able to do X, Y, Z. But that is something that I could see like as that becomes more available and more usable, like that's going to be an incredible tool in kind of the crypto space's toolbox.
One thing that I think is kind of underrated is people like to talk a lot about homomorphic encryption, but there's some problems with homomorphic encryption if you're doing outsourcing and you want somebody else to do the computation for you. You don't actually know that the computation the person did is your computation, especially if they're doing multiple. They could potentially be swapping the answers between them. So there's actually a field that I feel like doesn't get talked about a lot, which is verifiable computation, which is answering the question of, did the person do the computation they were supposed to do? Mm-hmm. And so like, for homomorphic, I could ask you to do an add, but you could do a multiply instead or something like that. And how do I know that the answer you gave me is the right answer? And so I think that has a lot of if you can implement a lot of these verifiable computation things that require like circuits and things like that to help you like say like, oh, I already did these blockchain computations to verify the state transition or something like that and like record it on chain. I think that's like kind of like what some of the roll-ups and stuff are trying to do.
I have another I wanted to finish off the thought on the AVM. Again, I feel like Stephen and I probably had these conversations in private, but I just know that everybody else out there is interested. So I'll go ahead and reiterate them. Can we spitball on some potential feature extensions for the AVM? So as I remember, ones we had talked about were potentially a zero knowledge proof one, post-quantum crypto, BLS signatures, Schnorr signatures. Is there any other that come to mind?
Yeah, so one thing, and I think you had touched on this a little bit earlier as well, was like proof of work involvement. So proof of work is really interesting. So for the VMs in the Avalanche network, the VM can define its block issuance pattern. So even though like the Avalanche consensus eventually like decides which block is accepted or rejected, the actual proposer mechanism is not necessarily defined inside the actual Avalanche protocol. And so so what that means is that it's actually very simple to say, well, actually, we want it to be a proof of work proposed, but Avalanche decided, VM. And one thing that was really interesting that we very specifically made possible when we were defining the feature extensions, or like this is something we had in mind when we were doing it, is the ability to implement a feature extension that does proof of work minting of a token. And so rather than necessarily just having a variable cap asset that says like, oh, this asset is, or like a fixed cap asset that says there's this many tokens, or there's a variable cap asset that's like this key owns like the ability to mint more. You could also define a proof of work minted asset to say like, here is the feature extension. It has this initial balance. And then when you mine on it, you get some emission rate. So that's one feature extension that I'm definitely very interested in someone implementing.
And what does mining mean? What does mining mean?
So mining it's just the same idea as what you would normally think of. So you could say like the transaction hash is, has some number of zeros leading it, and then you could adjust the difficulty. So it's the exact same like notion of say like a proof of work, like, Ethereum or Bitcoin, like lottery, and with a difficulty adjustment. So you could do that, and that's definitely something you could implement as a feature extension and put into the AVM. And I would love someone to implement that. Yeah.
Got it. Okay,
All
very
right.
cool.
I have one last question from Twitter to end on.
Mhm.
We have one user named tcrypt25519 asks, how does Stephen feel about Tom Brady becoming a BTC bro?
Yeah, so the first crypto. So okay, so going back, I'm from New Hampshire. I'm a big New England sports fan, and especially football. Tom Brady was at the New England Patriots for like 20 years, and he was a quarterback there when I was first seeing football with my own eyes, basically. I'm a big Tom Brady fan, big Patriots fan. Super happy with the Bucks with Brady winning his 7th Super Bowl. I had a blast with that, rooting for him again. I'm very excited about the Pats versus Bucks game. I think it's week 4. So we'll see how that goes. Anyways, so that's the background, and there's an Easter egg in AvalancheGo about Tom Brady if people start looking for it. But
Is it really interesting?
yeah, for sure. So touching on the Tom Brady being a BTC bro, I mean, the first thing everyone hears about in the space is Bitcoin, right? So that was the first thing I heard about, and so I think as the space continues to mature, I think that we'll see more of these kind of like celebrities and other people, seeing more of like these other tokens, and yeah. So I know that was a joke question, but it was a real answer to it. And by the way, the T-Crypt, that's Tyler.
Yeah, I know.
No, I know but I was just wrapping it up for the listeners. But yeah, so I think he's pretty aware of the Easter egg. So
yeah. So I say one funny thing about that I did not expect when I started my work at Ava Labs is that I would be working at the intersection of all of my interests, not even computer science related. And now I'm working with like professional sports with tops in Bundesliga, and who knows? And even like maybe some video games one day too, as we're trying to like get into the gaming space. And
Connor needs to pick up his phone and call Tom Brady and get him.
Surprisingly, I'm probably not as my like Kevin Bacon number is probably getting a lot lower.
At this point, it probably is. You're right.
Yeah, we don't. We don't have any NFL work in the books on, but who knows? Maybe one day.
Got it.
We'll get the Tom Brady autographed NFT, and we'll make sure to get you one.
Okay, so I do have one more question, and I think we could probably call it. It's been about 2 hours, and I really am grateful for your all's time. And I don't know that there's an answer to this yet, but I get it every single day. How are cross subnet transfers going to work?
Yeah, so cross subnet transfers, really the whole subnet architecture has kind of taken a backseat just because of us fleshing out everything like security wise. But so cross subnet transfers, the kind of the key idea with that was that because every node is required to be part of the default subnet, the plan is for the kind of like the workhorse part of the cross subnet transfers to happen on the P chain, the platform chain, and that becomes a lot easier. And this is part of the design of the platform chain, is that the platform chain manages the validator sets of all the other subnets, which enables it to then kind of act as this source of truth for the different subnet transfers. So that's kind of the key idea of it. So we haven't really like fleshed out like our entire like subnet implementation just because we've been really busy. But yeah, so that's kind of the rough idea of it. There was a couple other ideas that people had floated around. I think some of them, I think this one I saw on Twitter, but using like a bridge between subnets, that'll definitely work. I don't know that was that's our plan for the kind of the actual backbones cross subnet transfers. But if as we're continuing to develop stuff, that's definitely an option. And who knows, that might be something that happens kind of in the early days as we're still implementing the rest of it. But yeah.
Okay.
So yeah.
Got it. Well, yeah. First off, thank you for your time, man. Really, that was awesome. That was so insightful on so many levels. I can't even tell you. I'm gonna enjoy going back and watching this again and absorbing some of that a second time. You're welcome anytime, of course, man. I'll extend the offer to you. If you ever got something you want to talk about, you want to join us, let us know. You're welcome anytime. And
do you have anything you need to what's the word? It's not sell, like a Twitter account.
I'm not the only thing that I'm selling is my GitHub account. So
okay, all right. Where can people follow you on GitHub?
Yeah, follow me on GitHub. It's Stephen Buttolph or whatever it is. I don't know. Hey,
we'll put it in the description. We'll link it.
Yeah, I'm not super active on Twitter. If people tweet at me, I'll probably see it, but I'm definitely not your daily poster kind of guy. But
star the AvalancheGo repository.
Yeah, go star the AvalancheGo repository. Like fork the heck out of it, but no, yeah, like, comment, and subscribe, anyway.
Are you interested in doing presentations? I know you don't put yourself out there a lot, and it seems to me like a lot of people would probably like to hear you talk more. Are you interested in that kind of thing?
So I've been procrastinating doing like a deep dive on Avalanche subsampling, just like how the technical implementation of sampling. So I know we were trying to wrap up, but so I've spent like a lot of time optimizing for absolutely no reason the sampling algorithms. So I'll oftentimes talk about like, oh yeah, I spent like a ton of time implementing this, and people will be like, oh, is it like a big bottleneck? No, it's not at all. But it is. I consider it super optimized. I'd be very interested if any of the listeners or you guys have any ideas on further optimizing it. But yeah, so there's multiple different algorithms that are used with benchmarks that are run during initialization to pick like different algorithms based on the distribution of the weights and stuff. So I spent a lot of time optimizing this just for fun. And so I've been procrastinating doing like a kind of a blog post on like all the different things that we've kind of looked at and kind of the things that we've learned based on just off the sampling stuff, which is really unnecessary, but really interesting. So I would say yes, I guess is the answer to your question, but
yeah. All right. Yeah. Let's reach out to Steve. Let's get him on stage and give him more presentations. All right. Connor, any last thoughts?
No. Yeah. So yeah, thanks so much for being here, Stephen. It was really insightful for me too. Yeah. Glad we got to, we don't talk anymore. I was on the platform team for like a month.
Oh yeah, for sure. And you're still in New York, right?
Oh, I was never in New York. I live in Maryland.
You were never in New York? Oh, all right. Well, I thought that you were in New York after we had left for COVID, but
no.
Anyways, whatever.
Okay.
I was gonna say I moved. Yeah. Anyways, yeah. But yeah. Anyways, yeah.
Okay.
Great being here. I love talking to you guys. We should definitely talk more.
Yeah, absolutely. Yeah. The invitation is there, so I'm sure we'll have you back on the regular. All right. Thanks, everybody, for tuning in. That was a great interview. I learned a lot. I'm hoping that you did as well. And we will check you guys next time. Thank you so much. Cheers.
See you guys.